All right, section 4.2, apply congruence and triangles. So in your box that says congruent figures, in that same box that says actually congruent figures, draw these two triangles just like they are and label them. And then in the big box, put in the definition. The definition of congruent figures is, in two polygons, all parts of one figure are congruent to the corresponding parts of the other figure. And you can see our two triangles have all those congruent marks on them, but they're not facing the same direction. But if we were to turn that second triangle like 180 degrees so that the T is on top, the R is on the bottom, and the S is pointing to the right, you'd see that everything matches up. They all correspond with one another. So even though they're not facing the same way, there are still those corresponding parts. So corresponding parts are angles and sides that are in the same position of each figure. And we're going to list those here. So give yourself a little bit of room to list these in your definition box or in the box on the left as well. If we look at our angles, what angles correspond with one another? If we look at angle J, it corresponds with angle T. See, both of those have the 3 arc marks showing that they're congruent. We also say L corresponds with R. They both have 2 little arc marks. And K and S correspond with one another. So J and T, L and R, K and S. Those would be your angles that correspond. We also have sides that correspond. So if we see from J to L, if our side is JL, we would say that corresponds with TR. JL and TR. Yes, I should have shown that J and T are congruent. I could have wrote the congruent symbol in there instead of the and symbol. I'll write in the congruent symbol for the sides. We'll look at one of our other sides, LK. LK is going to be congruent with RS. We have one more side. JK will be congruent with TS. So those are all of your corresponding parts for these two triangles, the angles and the sides. Now at the bottom we have the definition for a congruence statement. And this is a list of corresponding vertices in the same order. This, probably more than anything else in this entire unit, is what you guys are going to be getting wrong, or most likely to get wrong. And that's writing your congruence statement correctly or identifying a congruence statement that is incorrect, because the order of the letters matters. So it's a list of corresponding vertices in the same order. So if we're looking at our triangle above, or our triangles above, we could say this triangle on the left is JKL. So if I name that triangle JKL, I have to make sure my vertices, my letters, match up with the corresponding letters of the other triangle. They have to be in the right order. So it's going to be congruent with, so we said JKL, so we would say TSR. We have to go around the triangle in the same direction, TSR. So when you're creating your own congruence statement, it doesn't matter which vertex you start with, but its corresponding vertex has to be the first vertex in your other triangle. So J corresponded with T, angle J, and angle T. So those both had to be first. Then K and S, and L and R. And so you can go either direction around the triangle, but they do have to be in the same order. They have to match up. You will have some questions where this congruence statement might be mixed up a little bit. It may say, are these two triangles congruent? And they list JKL congruent to SRT. That would not be correct because the second triangle was not listed in the same corresponding order as JKL. So you do have to pay attention to the order. The order matters. Third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And that should make sense. If you've got two angles that are congruent to two other angles, that third angle is going to have to be the same because all three angles have to add up to 180. So if one of them is 20, one of them is 30 in one triangle, and one is 20 and one is 30 in the other triangle, then the only thing that can remain is a 130-degree angle in both of them. So anytime two angles of two triangles are congruent, the third angle is also congruent. So example number 1, identifying congruent parts. So we need to write a congruence statement for the triangles and identify all pairs of congruent corresponding parts. So we have our two triangles here on the right, and you can see they're not in the same position. One of them's kind of on its side or almost upside down. So this little blurb off to the side is giving you a hint, maybe helping you out. You can redraw the triangles so that they're in the same position to help you identify those corresponding parts a little bit easier. So you can see that they turned the triangle GFH so that that right angle was in the bottom left, just like ABC. So we need to write our congruence statement. So in this diagram, it indicates that triangle ABC is congruent to triangle what? And we have to go in the same order. So A corresponds with F, B corresponds with G, and C corresponds with H. So there would be our congruence statement. Triangle ABC congruent to triangle FGH. And our corresponding angles. We just said those. A corresponds with angle F. Angle B corresponds with angle G. Angle C corresponds with angle H. And then our corresponding sides. Side AB corresponds with side FG. Side BC corresponds with side GH. And side CA corresponds with side HF. So those would be all of your corresponding parts and your congruence statement.